Hi, today we learned about the power rule of exponents. So I'm going to go over what we did in class. We started with some bell work. Yesterday we learned about the quotient rule. Quotient means divide. We learned a shortcut that if the base is the same, so x and x, then we're allowed to just subtract 13 minus 4. So 13 minus 4 is 9, so our answer is x to the power of 9. Now this just says, what does y parentheses 4 mean? Well, because there's nothing else inside the parentheses, well then it really just means y times y times y times y. Actually, I'm realizing now, first what I need to tell you is that because y is inside parentheses, 4 is outside, what we do is we put this on the y, so that becomes y to the 4th. And then it means y times y times y times y, right? If there was something else in here, like a 2, we would also put the 4 on the 2. So it'd be like 2 to the 4, y to the 4. Yeah. Fun fact. Okay, solve the equation. I'm going to write it over here so I have more space. This is solving a two-step equation. I like to draw a wall on my equal sign because it reminds me that whatever I do on one side of the equal sign, I also do on the other side of the equal sign. We have to get rid of the thing not attached to x. That's really easy to tell when it's multiplication. But here we have a divide and a plus. The divide is what's directly attached to the x. Most commonly, not always, but most commonly, it's the add or subtract that you're getting rid of first. So the opposite of a plus 3 is minus 3. And then positive 3 minus 3 is 0. I like to cross it off. Some people like to write 0. Awesome. So we still have x divided by 7 over here. And then 12 minus 3, just 12, 11 to 9, equals 9. Now we have x fraction 7. Well, fraction just means divide. What's the opposite of divide? Multiply. So I'm going to multiply by 7 on both sides. Divided by 7, multiplied by 7, those just become 1. Like, what I mean by that is because multiplied by 7 divided by 7, it looks like this. 7 divided by 7 equals the number 1. So I like to just cross it off. Some people like to write a 1. Cool. And then we just have 9 times 7. Okay, I'm going to use my finger trick. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. 63. You could have used your calculator too. So x equals 63. So that was our bell work. Then our goal, I had you write down, I believe on page 10 in your notebook. I can simplify exponents using the power rule. And then you did some work, teamwork, just on page 10. So like past days, we've had a couple of pages. Today, there's just one page. So let's go take a look at page 10. Power rule. I can simplify exponents using the power rule. Okay, cool. I can simplify exponents using the power rule. Okay, what does x to the 5th parentheses squared mean? There are a couple of different ways to think about this. I am going to show you one way, but if you're like, Miss Freeman, I thought of a different way and it still got the same answer. That's awesome. That is fantastic. I love it. I'm going to look just inside my parentheses first and think about what does x to the 5th mean. It means 1, 2, 3, 4, 5 is what it means. So really, I now have just this whole thing squared. Again, from this point, there's even a couple of different ways to think about it. Great. I'm going to show you the way I think about it. Well, squared just means I have what's inside the parentheses 2 times. So I have this, 1, 2, 3, 4, 5, and then I have it again because I have to square it. 1, 2, 3, 4, 5. So I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X to the 10. Okay, what's a faster way to simplify x to the 5th, all of that to the power of 2, than writing it all out and counting? Well, the numbers 5 and 2, what can I do with those numbers to get the number 10? I can multiply. So our trick this time, our power rule that we're using, our trick this time is when there's only the one base, notice how there's not two x's here. I'm not worried about like, oh, is it an x and a y? It's just there's an x. And then I've got an exponent. And then that's to the power of another exponent, right? It's called the power rule. It's to the power of another exponent. Then you are allowed to just multiply these two exponents together. There are some challenging things about this, so I'm going to go through the examples and show you, right? A times B. So our first one, like nothing crazy here. 3 times 5 is 15. Now this one, the 7 has the base. So has the exponent. The 7 is the base, has an exponent. So we just leave 7 alone. We literally only mess with the exponents. Just like here, we only messed with the exponents, okay? 4 times 2 is 8, so we left 7 alone, and it became an 8 up there. Now let's look at some more of these. I've got a couple of challenge questions down here, or examples. Earlier I said in our bell work that if there's something else in it also, you got to put that 5 there also. So I'm allowed to do my trick with the 3, but because there's this 2, it doesn't have an exponent, but it's inside the parentheses, then I also put a 5 on that 2 as well. Because it's in the parentheses, that means it also has to be to the power of 5. So this kind of mess ends up looking like this. 2 to the power of 5, and that's a thing on its own. And then x, and I've multiplied the exponents together. So let's look at just multiplying these exponents together. 3 times 5 is 15. Well, I'm not actually going to leave this as 2 to the power of 5. I'm going to simplify this part as much as I can. I'll type in my calculator 2 to the power of 5, enter, and it equals 32. 32 x to the power of 15. All right, now this is different because there's the 3 is not inside the parentheses. So the 3 just stays the same. So I'm noticing the notebook is wrong. 3 just stays the same. 3 just stays the same. So 3, because it's outside the parentheses, like we don't care what else is happening, it's outside. So all we got to do is what's inside. 6 times 4, 6 times 4, so 3 times z to the power of 24. Please make sure you fixed that example in your notebook, because that's important. All right, and then some practice that you did with your team. Looks like we've got a few of them down here. Starting easy, 4 times 3, right? Nothing tricky there. A to the power of 12. Okay, it feels more challenging because there's a number, but nope, that's the base. So we're just going to do 4 times 2 is 8. Now, if it said, what's the value of this? Then yeah, in your calculator, do 5 times 8, enter, and put a number. But when it says simplify to a single positive exponent, is what I would normally say, then that's how we do that. B to the power of, now these are both negative. Well, negative times a negative is a positive, so it's just positive. 8 times 3 is 24. Okay, same over here. Oh my goodness, B and 6, they look so similar, huh? This one's now a 6. It has an exponent, so it just stays the same. Negative times a negative is a positive. 7 times 4 is 28. Now you might ask, well, what if it was negative 7 times positive 4? We're going to learn about that tomorrow, I think. Okay, over here. 5 is on the inside, so I've kind of got two things to do. I have to do 5 squared, and I do my normal thing. So I'll just write 5 squared over here. And my normal thing is c to the power of 9 times 2 is 18. But I'm going to write this as an actual number. 5 squared equals 25. And then c to the power of 18. And because most likely, the way I know, right, you might be asking, well, how do I know if I leave it as 5 squared, 5 to the 8 like we did up here, or I change it to a 25? Because most likely, like these are two separate questions. This one is just going to say simplify to a single positive exponent. This will probably also say simplify to a single positive exponent. We already have our exponent here that cannot be simplified anymore. So this is an exponent we can simplify more, so there's only one single exponent. Or it might just say simplify as much as possible. And to simplify as much as possible, 5 squared equals 25. So you just got to read the directions. Now this 2 is on the outside, which means it doesn't care what else is happening in the whole world. e to the power of 3 times 5 is 15. So those are some tricky questions. So then we went back to doing the exit ticket. And let's just take a look at some of these questions now. Notice how, like, in most of the examples we did, the 6 would have been like up here, written up here, so it's a little bit higher than the 3. That doesn't matter. It doesn't matter if it's a little bit higher or if it's written right next to it. It's still a power to a power, so the rule is still the same, x to the power of 18. Complete sentences. What is the power rule of exponents? Well, when you have a power to a power, you can multiply the exponents. There you go. Okay, extend your thinking. Couple ways to solve this problem. And if you found a different way and it still got the right answer, very cool. I'm going to start by looking at what's just inside. So just inside, I have y squared times y to the third. We learned a few days ago how to simplify that. 2y's, 3y's, in all we have 5y's. Well, I can't actually ignore these parentheses and to the power of 4. But what I've done is I've simplified the inside, so now it looks like something I'm familiar with. And I just multiply those two together to get y to the power of 20. So that is a condensed version of what we learned today in class. Have a great day.